In this video, you'll learn about custom metrics for deployment monitoring. You'll see a few popular examples of custom metrics for generative AI and predictive AI deployments. And then you'll see the process for creating a custom metric in DataRobot and submitting custom metric values to a deployment. Those two steps will be in code. Then, in the graphical user interface, you'll see how to modify the layout of metrics and how to configure notifications and alerts. Understanding how to work with custom metrics is important because they bring visibility to your entire AI landscape, allowing each deployment to be monitored with use case-specific metrics. Having metrics and notifications in place is necessary for operating AI at scale. Custom metrics that you define are used to supplement the out-of-the-box metrics that DataRobot provides for each deployment. The standard metrics include everything on these four tabs: service health, data drift, accuracy, and fairness. Your custom metrics reside on the Custom Metrics tab. You control the name and definition of each. This deployment was created a few days ago and has 6 custom metrics. This happens to be a generative AI use case, so you see metrics related to LLM cost, response polarity, and response readability. The process and functionality for working with custom metrics is the same for generative and predictive use cases. Each of these tiles is a custom metric that was previously defined and assigned a unique metric ID. After creation, the metric ID and definition is locked, but other fields remain editable to change the name, baseline values, and display options. The Settings tab allows you to define metric thresholds corresponding to yellow at risk or red failing. It only takes a few seconds to add a new definition and configure the notifications. The rest of this video will show the process of creating these 6 metrics from scratch, following this AI accelerator available on DataRobot Community GitHub. You can follow along and build this use case for yourself. All the assets are provided. This is the exact notebook that created the deployment that we saw earlier with its 6 custom metrics. I'm going to place the notebook on the left side of the screen and the deployment on the right side of the screen. The final cell in this notebook is sending some test data to the deployment. If I execute this cell 3 times and then refresh the metrics, you'll see the timestamp now says a few seconds ago, and the metric values have changed. For the purposes of this tutorial, I've started a fresh copy of this notebook, and I've run the notebook already up to the point where the deployment is created, but the custom metrics do not exist yet. Let me orient you briefly to the use case and to the functions that are used by this notebook. Then we'll create the 6 metrics and begin populating them. This generative AI use case is for automatically drafting outbound customer emails to notify customers about the status of their shipping containers. When I enter the ID number for a container, an email is drafted. You could imagine a system that iterates over all shipping container IDs every 3 days and provides updates to the customer. Here's one such email. For this use case, it's appropriate to create metrics to evaluate the reading level of the generated email, the polarity of the generated email, and the LLM cost incurred. There are 2 other clever metrics that attempt to quantify the productivity gains of proactively sending emails to customers versus a representative needing to field inbound phone calls. Back in GitHub, you'll see that there's a helper file named utilities.py. Inside this file are the functions create custom metric and submit custom metric. I've uploaded the utilities.py file to the notebook's file area. That will allow me to import functions from the file and use them in my notebook. Refer to the custom metrics documentation for a deeper understanding of these helper functions. Custom metrics can be created using code or created in the UI by clicking Add Custom Metric. This will bring up the dialog box requesting all the same information that's passed in this function. The author of this AI accelerator has grouped the 6 custom metrics by business purpose. In the total cost of ownership section, he uses information from the Azure OpenAI pricing table to define how LLM costs should be calculated. The cell below uses the Create Custom Metric function shown earlier to add the custom metrics to the deployment. We can see that happening in split screen mode. The next section creates two user experience metrics focused on reading levels. Rather than reinvent the wheel, the exact calculation is provided by the TextStat package. In this cell, the two metrics are defined. In the cell below, they are added to the deployment. This process repeats for the polarity metric. We want to be able to catch very negative emails reporting very bad news and call the customer personally instead. Polarity is defined with the help of TextBlob and then created. Finally, the two productivity metrics are defined and created. Productivity metrics such as these allow the organization to calculate the average or cumulative productivity gains from the generative AI solution. You can see in the definition a few assumptions about the relative cost of a customer phone call versus an email. Having created all 6 metrics, let's generate some emails and send the associated metrics to the deployment for monitoring purposes. This cell defines a function named getCompletion. Inside, you'll see the container's tracking information concatenated into the shipment info. You also see the prompt that asks the LLM to generate an email based on the shipment information. This line calls the LLM and stores the response. This example has a clever guard model override that substitutes a different message if the generated email has very negative polarity. Here we see the values of the 6 custom metrics being submitted to the deployment. It's a best practice to wrap the metric submission with the response generation to make sure none are missed. This cell generates a response for a specific container that has been hard-coded. It's bad news for this customer. The container is delayed. The next cell generates an email for a random container in the database. Let's generate a few emails and then check in on the metrics. That's 1. That's 2. That's 3. Now let me go ahead and refresh the metrics. Success. It all seems to be working correctly. For a real use case, this would conclude the prototyping phase. If everything is functioning correctly, the deployment can now be used for a batch or a real-time business process, and all usage metrics will be properly recorded. We hope this tutorial gives you confidence to work with custom metrics in DataRobot. Each deployment has numerous standard out-of-the-box metrics and can have up to 25 custom metrics, all with alerts and notifications.